The aim of any pesticide treatment is to distribute the right amount of chemical on target to get the required pest control and to minimise the chance of affecting any non-target areas. Applying too much pesticide increases your costs. It may cause damage and it may also leave unacceptable residues in your produce. This means that your application equipment should be well maintained and accurately calibrated to make sure you deliver the right amount of pesticide. Calibration is all about making sure you're applying the right amount of chemical, and the right amount of chemical is as defined on the label. During this section, we're going to be looking at calibration by working through Assessment Task 5. And to do this activity, you'll need the calibration worksheet or the boom spray, which is provided in RawBiz Online, access to the robot label. You may not need to print it off, but just to have it open on your computer, a calculator and a pen. I suggest you pause the video at this point to gather these up. Looking at your worksheet, your calibration worksheet, you can see that you're asked to gather up a series of measurements and to do a couple of calculations. We're looking at an example, a little demonstration of a small boom spray, one with just 3 nozzles on it. The first measurement we're asked to take is the spray width. And you can see on your screen we work this out by multiplying the number of nozzles times the nozzle spacings. In our example here, we have 3 nozzles spaced at 0.5 of a metre, giving a total spray width of 1.5 metres. Make a note of this on your worksheet. The next measurement we need to take is speed. One way of calculating speed, if you are not able to read it directly from your application equipment, is to measure at a distance of 100 metres. Measure how long it takes to drive the 100 metres at normal operating speed with the sprayer attached and half full. In our example, this took 30 seconds. To work out the speed, we then multiply the distance by 3.6 and divide by the time. So here we would be multiplying 100 metres times 3.6 and divided by 30 seconds. 100 times 3.6 will equal 360 divided by 30. I'll just give you a little minute to see what you get. And hopefully you got 12 kilometres per hour. Now let's look at what we actually get from our little sprayer setup. We set the operating pressure as we are going to be using it, turn on the sprayer and measure the output from each nozzle in 1 minute. And here are some participants in one of the courses doing it. You'll also notice that our little setup has a 50 litre tank, and that's a bit of information that we'll need a bit later on. At the end of the minute, the amount of water that has been collected from each nozzle is measured, and here were the results that were obtained. One nozzle put out 425 ml, another nozzle put out 400 ml, and third nozzle put out 398 ml. Add together all of those to get the total nozzle output from our spray unit. The total equals 1,223 mils. You'll see from your worksheet that we're looking for the answer in litres. So dividing by 1,000, it comes to 1.223, or we will be just using 1.2 litres per minute. Make a note of that in the section total nozzle outputs equals 1.2 litres per minute. You'll notice that there is a message here that says to replace any nozzle which varies more than 5% from the rated output. So at this stage in your calibration, you would be checking your nozzles and comparing it to the manufacturer's rated output. If it was more than 5% variance, then that would indicate wear on the nozzle and the nozzle should be replaced. So let's have a look at what we should have so far. Under spray width here, we would have noted that it was 1.5 metres. Our speed in kilometres per hour was 12 kilometres per hour, and our nozzle output was 1.2 litres per minute. Let's see if you can do the calculation. In here, we put 1.2 for the total nozzle output times 600, and on the bottom line we will have spray width, it's 1.5 in this box, times the speed, which is 12 kilometres per hour. I suggest you then multiply across the top 1.2 times 600 and write the answer down. Then multiply across the bottom 1.5 times 12 and write the answer down. I'll just give you a little minute to finish that calculation. You might like to pause the video and to take time to have a look at what you've done so far. When you come back, check your answer and see if you've got 40 litres per hectare as the application rate. What we're saying here is that that little setup, the little spray unit setup, would put out 40 litres per hectare if we drove it around at 12 kilometres per hour with the pressure and nozzles as we have set up in this example. Our next step is to think about the job we're actually doing. And you'll see on your worksheet that the example is based on controlling red-legged earth mite in pastures. I've pulled just the page of that out from the row-bore label. You can see that the pastures section here, so we've got pastures, control of red-legged earth mite, and provided we're in one of these states, it's legal to do so, and the rate it is suggesting is 55 to 85 mils per hectare. We're given a range here, and so we would come over to the comments section to see if we can get any further guidance on what would be the correct rate. I notice over here it says use a higher rate in New South Wales. So let's say that we are calibrating this for use in New South Wales and use the 85 mils per hectare rate. So on your worksheet where it says recommended rate, we want to put in 85 mils but it tells us to put it in litres per hectare. So our 85 divided by 1000 to convert it to litres becomes 0.085. So the recommended rate is 0.085 litres per hectare. Enter the 0.085 litres per hectare here on your worksheet, which is in the bottom half of your worksheet. We know that the tank size is 50 litres and that the application rate we've just worked out in the first calculation was 40 litres per hectare. So to work out the amount of chemical product we should put in our tank, the amount of rogol we need to put in the tank, we multiply the recommended rate by the tank size on the top line, which is 0.085 times 50, and divide it by the application rate, which is 40 litres per hectare. Just pause the video at this point and complete that calculation for yourself. Welcome back. Just check your answer now and see if you've got 0.106 litres. We would normally change that into millilitres by multiplying by 1000. So that would become 106 mils to be added to the tank. One of the things I like to do is to ask, does this make sense? What we know we've got is a 50 litre tank and our application rate is 40 litres per hectare. This means that we will be able to do a bit more than 1 hectare with a tank full of mix. Our label tells us that we need to put out 0.085 or 85 mils per hectare. Therefore, we would be expecting to put more than 85 mils per hectare, more than 85 mils into each tank of mix, because we're expecting to be able to do a bit more than 1 hectare. Therefore, the answer of 106 mils appears to make sense. Now that's a very useful check to do, just to make sure that you haven't got your answer wrong by a factor of 10 or so. It's very easy to get those decimal points mixed up, but having that little check at the end makes sure that you pick up a mistake. That's all that we'll be doing on calibration, but I want you to remember that calibration applies to all application equipment, not just spray equipment. Remember, calibration is about making sure you get the right amount of chemical delivered to the target. We've made calibration worksheets available for other types of equipment as well, and you can download these from the additional resources section of WorldBiz Online.